Let's now take another example, carbon monoxide, in order to illustrate the method which is slightly different from the method that we have seen before, which allows us to predict or draw possible Lewis structures. We take carbon monoxide this time as an example. This new method begins with calculating the total number of electrons in this formula, assuming all atoms obey the octet rule. So the total number of electrons will be 8 plus 8, and that is 16. So 16 electrons total. Remember, this is not the valence electrons, okay? This is the total number of electrons, assuming all atoms obey the octet rule. Next step would be to calculate the total number of valence electrons. Well, there are 4 from carbon, because carbon is located in group 4a, therefore it has 4 valence electrons. And now we add 6. 6 is the number of valence electrons in oxygen, because oxygen is located in group 6a. So 4 plus 6, this is 10 valence electrons. If we divide the number of, subtract the number of valence electrons from the total number of electrons, we get 6 bonding electrons. So 6 bonding electrons is the result here. If you divide 6 by 2, and why do we do that? Because we need 2 bonding electrons to constitute a bond. So if you divide the total number of bonding electrons, which is found as a result of subtraction of the number of valence electrons from the total number of valence electrons, assuming all atoms obey the octet, we get the number of bonds. So 6 by 2, that is 3 bonds. So there are 3 bonds, therefore, expected in the Lewis structure, or a possible Lewis structure, of carbon monoxide. Let's see that. Well, we draw carbon. That's the carbon atom, and that's oxygen atom. And then we draw a triple bond. So there are 3 bonds, if you like, a triple bond between carbon and oxygen. What we need to do next is we need to satisfy the octet for each of these atoms. So carbon now has 6, so that's now 8, and oxygen is now also surrounded by 8 electrons. Oxygen and carbon have satisfied the octet rule. If you check or verify the number of valence electrons used up in this Lewis structure, you will find that it's 8 plus 2, that's 10. So 10 valence electrons. So this is satisfactory. Now, if you look at the number of bonds, you will see it's actually 3, and that goes also in accordance with the information that we have found before. So this is therefore reasonable. So this is therefore a possible Lewis structure for carbon monoxide, using a slightly different method from the one that we have seen before, or we have used before, taking into account the total number of electrons, assuming that all atoms obey the octet, and we subtract from it the number of valence electrons. We get the number of bonding electrons, which is 6 in this case. If you divide bonding electrons by 2, you get the number of bonds possible in a Lewis structure.